and I'm now working as an assistant professor at the Nankai University of China. And today I'm going to share some information about the spatial patterns of the spatial temporal patterns of the intensity and extent of surface UHI based on the LCZ scheme. And the other authors include Professor James Wood, Professor Chao, and Professor Aaron. So I think most of us are quite familiar with the UHI effect. We have this kind of organization, and then we have changes in terms and energy balance in cities, and then we got the temperature difference between urban and rural areas. So what I wanted to emphasize is that despite the mean level of urbanization in China has already passed nearly 65 by this year, but we still have much room for China to improve, particularly comparing to the mean level of developed countries. So we could say we have a urgent need to mitigate urban heat island in Chinese cities. And then I think you also will be quite familiar with this chart. Usually we have different kinds of UHI effects measured by different methods. And here, this study focused on the surface UHI due to its advantages in spatial coverage and large-scale analysis. So we also already know that the LCD scheme has already been applied into many UHI studies, but I would say there might be some research gaps. The first one is if we use the time series LCD data, there may be a temporal inconsistency problem. That means sometimes the LCD build times may change back into natural types in a quite short time. And the second point, and the second gap may be most of the studies focus on the intensity of UHI effect, not including the actual influencing areas of UHI. And last but not least, we also need to consider the influence of background climate on both intensity and extent of the UHI effect. So our study aims to answer these two questions. The first one is what are the spatial temporal patterns for both intensity and extent of UHI effect? And the second one is what's the influence of background climate on these two UHI indicators? So let's move to the next part, our study targets. Here we focus on 8 large cities in China. Most of them, oh no, it's all of them are high-rise, high-density cities and has experienced fast urbanization and economic development during the past, let's say, 40 decades. This is the overall workflow of our study. In general, we have 3 parts. The first part is we did a temporally consistent LCD mapping. Here, compared to the previous ODAF method, we made improvements in mainly 3 aspects. We put much more input sources, particularly the canopy height information, and then we refined our training samples by referring to much more stream view. And the last is also the most important. We did a temporal consistency check. Sorry. Let's go. And the second part of our methodology is to do a surface UHI analysis. We quantified both intra-urban UHI intensity and we proposed a UHI extent quantification method. And the third part is we did a correlation and regression analysis to find the influence of background climates on these two UHI indicators. So I will go into a little bit details to parts of the methodologies. The first one is about the temporal LCD mapping. Here we mainly applied 2 rules. The first one is in a short time, we will assume LCD build types won't change back to natural landscapes. And the second rule is we also assume LCD high-res build types won't convert back into the LCD low-res types. Let's say LCD1 and LCD4 will normally remain the same in the following years. And the next part of what I wanted to emphasize is about the method of quantifying surface UHI extent. The basic idea of this method is we wanted to find a breaking point between significant UHI effect and non-significant UHI effect. Let's say the areas of UHI intensity higher than the breaking point are regarded as the UHI influencing area, i.e. the UHI extent. So these are the LCD maps of 8 study targets in China in 4 separate years. And we also did the accuracy assessment and found that, generally speaking, we have accuracy of field taps for nearly 77%. And luckily, compared to the previous wood-done methods, we can improve the accuracy of field taps by nearly 10%. So we will say that the temporarily LCD mapping method could say has a good performance in a complicated urban context. And these are the mean surface area intensities for every LCD build type uh, in both summer and winter during day and nights in 8 Chinese large cities. From a temporal pattern from figure A to figure D, we could say that we have the maximum UHI intensity for uh, build taps on summer day and relatively low UHI intensity for build taps on winter days. And when we're looking from a spatial perspective, let's say from the upper side to the bottom side, i.e. from the northern part to the southern part of China, we could say that we have a decreasing trend for the intra-urban UHI intensity, with background climates becoming warm and white. And not surprisingly, we have the hottest temperature for LCD1 and LCD2, but relatively low UHI intensities for LCD9. Further, we did a correlation analysis between climate indicators, air temperature, precipitation, relatively humidity, and the intra-urban UHI intensity. Also, we could say there are significant negative correlations between UHI intensity and background climate, particularly during summer day and winter night. And what is interesting is that we found that LCD1, 2, and LCD4 will be much more likely to be affected by the background climates. So let's have a look at the advantage of the proposed LCD of the proposed UHI extent quantification method. Here we did a comparison between the surface UHI extent generated by the traditional Gaussian surface model, let's say the ellipse area, and then we and also the results generated by our proposed method are represented by the red color areas. So we concluded that the proposed method could capture the actual urban boundary much more precisely and could capture the so-called multi-core urban development modes. Let's say this isolated hotspot in Qingpu and Songjiang districts in Shanghai. And these are the absolute values of surface UHI extent in our study targets in summer and winter during daytime and nighttime. And not surprisingly, also we have the maximum value during summer days and relatively low value in winter days or nights. We also go further into the qualitative correlation between the background climate and surface UHI extent and found also there is a significant negative correlation between the relatively humidity and the UHI extent, particularly during summer day and winter day. But we found something a little bit interesting is that the urban area affects UHI extent much more significant than the background climate. So further we step into another regression analysis and found that among all the LCD types, LCD1 will drive the UHI expansion much more significantly. So lastly, we will say that we wanted to draw several planning recommendations based on our research findings. The first recommendation is, not surprisingly, we should restrict the area of LCD1 since it will promote the intensification of UHI and expansion of UHI. And the next point is, it's better to consider uh, replace LCD1 with LCD4. Since LCD4 has a relatively low surface UHI intensity, when accommodating a similar urban population as LCD1 and LCD2. But also we need to consider the driving effect of LCD4 on surface UHI expansion during some time. So we also wanted to note some things beyond these two recommendations. Beyond these two recommendations, the first one is we do need to consider the positive effect of UTI in severe cold regions or cold regions in some areas, and in particularly during winter nights. And also, we need to be aware that although the subtropical cities may have a relatively low UHI intensity, but usually they will face high absolute temperatures during summer seasons. So we also need to consider heat mitigations in these subtropical cities. So let's move to the key conclusions of this study. At the very beginning, we proposed two research questions, and here we could answer them. The first, the first question, we have the answer. Let's say we could say a obvious or significant spatial temporal pattern for both intra-urban UHI intensity and UHI extent. And also for the second question, we found quite different major influencing areas for intensity and extent of UHI. Let's say for the intensity, background climate accounts much more, but for the influencing area, the area of urban types, particularly LCC1, was the dominant influencing factor. So lastly, I have to say something about the limitations of the work. The first limitation is about the nature of land surface temperature. Because here we use the modest LSD product, and they are not temperatures for all relevant surfaces that will contribute to both heat stress and contribute to heat loading of buildings. And the second limitation is we still need to consider the impact of global climate change in our study. And the last one is we should expand our city samples to make a more large scale analysis. And so this is the overall introduction of this study. And thank you so much for listening.
Thank you very much, Ron. We do have time for questions. This man here.
That's another mic for the questions.
Just there, though.
Thank you. Interesting talk. What I was trying to understand, if you can elaborate on that a little bit. The UHI extension, is it physically the extension of the urbanization or due to the ongoing background condition itself? Because the urban heat advection matters as well to the rural conditions, right? So what do you attribute to the UHI extension? What is the major factor that you attribute it to?
May I help you? Can I help you?
So what is the major factor that you attribute in the physical process that is UHI extension happens?
You mean the behind physical mechanic?
Right.
mechanisms
Yeah.
for the UHI
Is it the
extension.
increasing urbanization or is the background condition with respect to urban heat advection itself?
I would say that you can say that the UHI extension is some kind like a spillover effect of the urban temperature. That means that we are not only have a UHI extent exactly in the same shape of our co-urban areas, but we'll have a large expanding areas around the co-urban areas. That means there may be a neighborhood influencing effects between the core urban areas and the rural or say suburban areas. And
I think it's more later. Okay, understood. Thank you.
okay, thank you.
Okay, let me ask a question.
Okay, thanks. Yeah.
The implication of this is that we should be designing for the urban heat island.
Yeah.
But tell
I
me,
know-
is that always the most important thing to design
Yeah,
for?
I know what you are addressing there. I know that sometimes we should say we need to combine urban heat island. We need to combine the urban heat. Because sometimes urban heat island now means we definitely have a quite high absolute temperature in our city areas. Urban heat island refers to the temperature difference between urban and rural areas. Now meaning that the urban temperature might be absolutely quite high. So the more precise expression should be mandated urban heat.
Yeah.
And for sometimes urban heat island may not be a bad thing for several cities with particular background climates. Let's say the cities located in severe cold or cold regions.
Or windy?
Yeah, particularly in wind days. Yeah. Okay.
But due to a glitch in the program, we actually have a little bit more time there. So if anybody, if you don't mind, thank you very much, Sean.
Okay, thank you.
If anybody would like to ask questions of Jason's presentation, please do so now. For whatever reason, there's a gap in the program and the next one's supposed to begin exactly noon. So would anybody like to ask a question about Jason about the test beds? I had to cut you off, Jason, but perhaps you could tell people exactly or precisely what you're asking them to do or to be, if they wish to be involved in test beds.
Oh, thank you. So this is all emerging. The test bed will be,
Well, first of all, maybe you could just define what a test bed is. A test bed is a place where they're taking lots and lots of measurements simultaneously, right?
right. So there's lots of activity going on now. For example, let me just take one example. The IFL program is a well-funded, it's a quite funded program of measurements and modeling, and with a lot of questions, of course, being challenged. And so they would like to see how they can work with WUDAP in what they do, because they see that this is an opportunity for them, and it's an opportunity for WUDAP as well. So there's talk about how they can benefit from this interaction. And so a test bed would be, for example, in Chicago. How can, from the IFL point of view, how can we take our measurements or even change our measurements or modeling to match what you need in WUDAP? And so there's a dialogue that will come about, and that will be organic. They will find out what can be done and then move forward. The benefit there is that from the WUDAP modeling perspective, I can speak to that, they can test the output of what we come up with. And that's a wonderful opportunity. So,
Okay. No, I'm sorry. You
No,
used up
we're
the
done.
entire period there.
I somehow did that, yeah.
Um,
We will talk.
So I'm going to ask our next speaker to come up here and present.